All right, so we are done with matrices and determinants. So that was chapter 10. And if it feels, I know this is completely new material, but just practice and reach out if you need help. I know it can be confusing what I'm multiplying and adding, and it's all new stuff. So please reach out if you need help. We're moving forward. We are going to start chapter 11, which is on conic sections. And we're gonna cover a few of them. So conic section is a curve that is formed when a plane cuts a cone. So you have a cone. This is the cone right here. And how can you cut a cone with a plane? So this is a plane. So if you see when you cut it, you will have this shape right here, and that's the parabola. You can also cut it like horizontally like this, and then the shape that you're gonna get is a circle. Or if you cut it at an angle, you will get an ellipse. And then if you cut it straight through vertically, you're going to get these two symmetric parabolas. So in section 11.1, we're going to study the types 1, the parabolas. And then in 11.2, we're going to study type 2, which are the circle and ellipse. And then in 11.3, we're going to do type 3, which is a hyperbola. So parabolas, we know parabolas that they look like this or like this, right? So it was even opening up or down. But we studied them from an algebraic point of view, from the point of functions. So we'll see that if we're looking at parabolas strict from a geometric view, we can also have parabolas that open to the right or open to the left. Okay, so we're not studying them from an algebraic point of view, we're going to study them from a geometric point of view. So this shape from a geometric point of view. And then we have circles and ellipses. And then hyperbolas are going to be like this. And then in 11.4, we're going to do shifted conics. So basically in 11.1, we're going to study parabolas from a geometric rather than algebraic point of view. And we're going to begin with a geometric definition of a parabola. All right, so geometrically, a parabola is a set of all points. What kind of points? Well, a certain type of points. Parabola is a set of points in the plane that are equidistant, so they are the same distance. That's what equidistant means, from a fixed point called F, which comes from focus, and a fixed line L called the directrix. So you have your parabola right here. Your F, the focus, is a fixed point right here. This doesn't move. So the things given to you are the fixed point F and then the directrix L. Okay? And the first point that is equal distance from F and from L is the vertex right here. And then if you look at any point, so if I look at this point right here, the distance from it to the focus and the distance from it to the line L is the same. That's what this means, this. So geometrically, this distance and that distance is the same. Similarly with this point. Or if I take another point right here, this point, the distance from it to the focus is equal to the distance from it to the line. So all of these points that are at the same distance to the focus and to this line L, they form a parabola. So geometrically, that's what a parabola is. All right. So let's see how to derive the equation of a parabola. So we have that we are going to concentrate on parabolas situated with the vertex at the origin of the xy plane. So we have the xy plane, and this is the origin right here. So we're going to place our vertex at the origin, and that have a vertical or horizontal axis of symmetry. So if you remember, the axis of symmetry is the line, the vertical line that goes through the vertex. Okay, so I need, if I look at a point x, xy, so a point P, xy, the distance from this point to the focus, which is right here, has to be the same as the distance from the point to the directrix, to the line y equals negative p. So where is this p coming from? So notice that the focus is a point on the y-axis, so it has 0 for the x-coordinate and p for the y-coordinate. So the focus has coordinate 0, p. It's just a point. Then, look what this is. Then if the focus is right here and it has coordinate 0, p, and the vertex is right here, the vertex is at the origin, that means that the coordinate of the vertex is 0, 0. So the vertex is a point on the parabola, so the distance from the vertex to the focus has to be the same as the distance from the vertex to the line. So that makes this distance from the vertex to the line, to the directrix, also p. So the equation of the directrix is y equals negative p, because this is just the equation of a horizontal line going through negative p. Okay, so I must have that the distance from the point P to the point F, the focus, has to be equal to the distance from the point P to the directrix, to y equals negative p. Okay, so then let's see what is the distance between the point P and the focus. So if you recall from geometry, if I have a point, if I have a point P1, which is x1, y1, and then P2, which is x2, y2. Why is it so glary? The distance between P1 and P2 is going to be square root of, you subtract the x-coordinate, so x1 minus x2 squared, or just x2 minus x1 squared plus y2 minus y1 squared. It doesn't really matter if I put x1 minus x2 or x2 minus x1 because I'm going to square the quantity. So that makes that the distance, so let's call it d. The distance between the point, any point P on the parabola, and the focus F is going to be square root of what is the x-coordinate of F. The x-coordinate of F, so I'm going to write in here, P has coordinate xy, and the focus has coordinate 0, p. So this plays the role of my x1, y1, and x2, y2. So this is my first point and this is my second point. So the distance between these 2 points is given by x2, so 0, minus x1, which is just x squared, plus, I'm just following this formula, y2, so the second point is the coordinate y is p, minus y1, which is just y. So that's squared. So this is the distance between the point and the focus. And now the distance between the point and the directrix is going to be square root of, well, the point still has the coordinate xy, and then this right here, a point right here, if this point is xy, what's going to be the x-coordinate of this point right here? Well, it still has x-coordinate, and what is the y-coordinate? The y is negative p. So I called this point C, so, or let's call it D for directress. Okay, so this has coordinate xy, and this has coordinate x and negative p. So it's going to be x2 minus x1, so x minus x, so x minus x squared, because this is x2, y2, and this is x1, y1. So x2 minus x1 is x minus x, plus y2 minus y1, so negative p minus y. Okay, so these distances have to be equal, because that is the definition of a parabola. So this is how we're going to get the formula. So what we're trying is to get the formula. I don't want to just give you the formula and be like, okay, this is it, go ahead and use it. So let's see how to get the formula. So how we're going to get the formula for the parabola. Alright, so these distances have to be equal. So I'm going to say that the left-hand side, I'm going to put that on the left-hand side, but 0 minus x squared is just x squared plus p minus y squared equals x minus x is 0, so it's 0 squared, and then negative p minus y squared is the same as p plus y squared, because I can pull out the negative, but the negative 1 squared is positive. And this, furthermore, this is p plus y, right? Because square root of this quantity squared is p plus y, but it's actually absolute value of p plus y. So then on the right hand side I have square root of x squared plus p minus y squared. Because this is a distance, I got to make sure that it's positive, so I'm going to put it in absolute values. So now I'm going to square both sides. So square both sides. On the right hand side I'm going to get x squared plus p minus y, everything squared, equals absolute value of p plus y squared is the same as p plus y squared, because the square is going to make sure that it's a positive quantity. So now I'm just going to calculate this. So x squared, p minus y, everything squared, is going to give me p squared minus 2py plus y squared. And p plus y squared is going to give me p squared plus 2py plus y squared. So if you just FOIL p minus y times p minus y, you're going to get this. And if you FOIL p plus y times p plus y, you're going to get that. So notice that I have the y squared here cancels with this y squared, the minus this one, the p squared right here cancels with this p squared. So all I have left is x squared equals, I'm going to add 2py to both sides. So I'm going to have left x squared on the left hand side equals 2py, and then plus another 2py, so 4py. So this is the formula for a parabola. From a geometric point of view, this is a parabola with focus 0p and directress y equals negative p. So notice that our parabola opened up, and this p was positive because it was above the y-axis, so this p right here was like, it's a positive number. But if p is negative, we are going to have a parabola opening down. So And then, sorry, and then we saw that we can also have parabolas to the left and to the opening to the left and opening to the right. So that's where we're going to go next.